closed tubes have one closed end and one open end. Organ pipes are like that. It has a displacement node, and let's see here, we're talking about displacement. So we have a displacement node at the closed end, which means we have a pressure antinode there. We have a displacement antinode at the open end. Okay, that's where the air here is just meeting the air outside, and it's the same displacement. Over here, the air is going to be fixed. Now, the difference between this and the open tubes is how much of a wavelength you can fit. So for n equal 1, we can fit a quarter of a wave, right? Because if you start with a node here to go to an antinode, you're only going 1/4 of the way through a wavelength, right? Then you would have to come down like this and do this to complete your wave. That's a terrible wave, but here's 1/4, then here's 2/4, 3/4, and a full wave. So in this case, our first wavelength, lambda, is equal to 4 times the length of the tube. So the fundamental frequency, again, is V over lambda, V over 4L. That is the fundamental frequency where n is equal to 1. For the next one, we have to fit 3/4 of a wave. That's all we get. But we don't get half a wave there because we wouldn't be able to meet the condition of a node at one end and an antinode at the other. So in this case, lambda, the wavelength, is 4/3 times the length of the pipe, and we have f prime is V over lambda. We put in what lambda is equal to, and this time we get 3V over 4L, which is 3 times the fundamental frequency. What do you notice it's missing here? N equal 2 isn't there. We then go on to the next one. We don't find an n equal 4 because of the constraints we've put on where the node and antinode is, and we get 5f. We only have odd numbers for n. The fundamental wavelength and frequency of a closed tube is different from the open tube. For the lowest resonating frequency, only 1/4 of the wavelength fits within the closed tube, and that's what was sketched on the previous slide. When we had the open tube, and we'll take the pressure variation, it went like this and came down. So what do we have here? We have half a wavelength. And we've got a sketch here. Here's the length of the tube, and then we've sketched it out so you can see the full wavelength here from the closed tube, and only 1/4 of it fits within the tube. Another difference between the open and closed tubes is for the open tube, we could have n is equal to 1, 2, 3, etc., all the integers. For the closed tube, because of the requirement to have a displacement node at the closed end and an antinode at the open end for all resonant frequencies, we only get the odd numbered harmonics. And we demonstrated that a few slides back. And this over here is my n is equal to 1. That's the fundamental frequency. So we still have the same equation, f sub n equals n times f sub 1, but we can only use odd numbers for n.